Now the topic is combination formula. This is also called as selection formula. If the set of objects are given to us, then in how many ways we can select the subset of those objects. This formula is used for finding the number of ways we can select the subset. For example, if alphabets are given to us, A, B, C, D, E, total 7 objects are given, and I want to select only 3. In how many ways I can select any 3 of them? Like I can select A, B, C, or A, B, D, A, C, B. This is wrong. This is the same selection. Interchanging of position will not give a new selection. It's called as permutation. Interchanging position is called as permutation. So there is another formula, known formula called NPR also. But this is nCr, that is combination, that is selection. So this is a known formula. Now, how we can write a procedure or a function for evaluation of nCr? Now, one important thing about this formula is, if the value of n, I am taking it as 5, then C, then R. R can take the values from 0 to 5. So it means I can find the values like 5C0, 5C1, 5C2, so on up to 5C5. So the value of R can start from 0 and the last number is same as n. So I cannot have R greater than 5, that is n itself, or less than 0. Now next thing, how to write a function for this. So I can write on a simple function for evaluation of this formula. I'll write a function here. Return type of a function is int, and let us call the function name as C, and it needs 2 parameters, that are n and r, integer n and integer r. Now for evaluation of this formula, I should know factorial of n, r and n minus r. So these factorials I can find out by calling function fact. That is, already we have written a function for finding the factorial. We have written iterative version also, recursive version also. So we can use any of those versions and we can find out the factorial of these. So for finding the factorials, I'll take some temporary variables t1, t2 and t3. t1 is factorial of n and t2 is factorial of r, t3 is factorial of n minus r. So I got all 3 factorials. Now I have the result, just I can return t1 divided by t2 into t3. These must be in the brackets because both are in denominator. That's all. It's a simple function for finding nCr value for any given n and r. How much time it is taking? Factorial function we have already analyzed, and it is taking order of n time, and this is also order of n, and this is n, and this is a simple statement, so it's constant time, so we can ignore that. So it is a 3n. So 3n means it is order of n, means degree of a polynomial is n. So the time taken by this function is n. It's a simple function. That's all. We can write a simple function for finding a combination value of given n and r. Now next, can we write a recursive function for this one? So for getting the idea of a recursive function, first of all we'll look at Pascal's triangle. So let us see Pascal's triangle. Pascal triangle shows that the values of nCr can be obtained by performing addition recursively. How? Let us see this. First of all, on the top the value is 1. Then on this side extremes are taken as 1. Then this extreme is 1. Then these two are added to get 2, and this is 1. Then this extreme value is 1. And this is 1 plus 2. This is 3. 2 plus 1. This is 3. And this one is 1. This side it's 1. And 1 plus 3, this is 4. These two are added to get 6. These two are added to get 4. And this extreme value is 1. So what these values are, let us see. This topmost value is 0C0 and this is 1C0 and 1C1. See, the value of n is 1, so r can be from 0 to 1. Now this row is for 2, so 2C0, 2C1, 2C2. Then this row is for 3, 3C0, 3C1, 3C2, 3C3. And the last row is 4C0, 4C1, 4C2, 4C3, 4C4. So if you want to find out the combination values for n as 4 for various values of r, you can take it from this row of Pascal's triangle. So from Pascal's triangle, we can find out the values of nCr, or else we can use this formula also. So already we have seen a function using the formula, but from the Pascal's triangle, can we write down a function for finding nCr value? Let us see. Let us observe Pascal's triangle. See, any value, like example 4C2 is obtained by adding 3C1 and 3C2. And how that 3C1 is obtained? By adding 2C0 and 2C1. And how that 2C0 is obtained is a direct answer. 2C1 is obtained by adding 1C0 and 1C1. So it is recursive. It's recursive. If I call this value as nCr, this value is obtained by adding these two. If n is 4 and r is 2, then what is this? 3, 1. So this is n minus 1. See, r is 2, so it is 1 here. So this is r minus 1. And other value is this one. So n, so this is n minus 1. C, r is as it is. So any nCr value can be obtained by adding n minus 1 cr minus 1 with n minus 1 cr. So based on that, I can define a recursive function here. Let the function name be c and it takes n and r. Then here for a recursion, I should define a small problem. Means when n is 0 or r is 0, what I should do? So for this, you can see here, when r is 0, return 1. When n is equal to r, return 1. So extreme points, those are 1 always. When r is equal to 0 or n is equal to r, return 1. So for small values, these are the small values, 1 are the small values. And when it is 1, if r is 0 or n is equals to r. Otherwise, we will add these two terms and get the result. So else return c of n minus 1 comma r minus 1 plus c of n minus 1 comma r. That's all. So this is a recursive function for finding nCr value, that is combination formula. And this recursive function follows actually Pascal's triangle. So it means if I am trying to find 4C2, it will call 3C1 and 3C2. So for 3C1 it will call 2C0, 2C1. For 2C1 it will call 1C0 and 1C1. And 1C0, 1C1 are directly 1. For 3C0 it will call this one and this one again. So it will make the calls from bottom towards top, that is bottom up calls are made compared to this Pascal's triangle. And whenever it reaches 1, it terminates. That is the last point, because when n is equal to r or r is equals to 0, we are returning 1. So that's all about combination formula.